Hi everybody. First off, I apologize for maybe the poor quality of my laptop camera, but we'll work with what we've got. A few people have asked me for another demonstration about the Exit Voice loyalty game, maybe with some different examples. So I'm going to record this quick video for you to possibly review tonight in prep for the quiz tomorrow. So maybe take a moment and pause the video here to write out the game tree so you can follow along. I'll walk through each of these components here so that way everybody's on the same page. So in this Exit Voice loyalty game, we have two players. We have the citizen, marked by C here, and we have the state, marked by S. We see that the citizen has the potential to move 2 times. So there's 2 nodes there. The state only moves once. There's only 1 node here. So we know that we need to account for 2 possible strategies for the citizen, and we need to only account for 1 possible strategy for the state. Okay. So at the beginning of the game, the citizen has 3 options available to them. They can either choose to use their voice, they can choose to remain loyal, they can choose to exit. If the citizen chooses to use their voice, then the state gets to move. And the state has 2 options available to them. They can either respond to the citizen's use of voice, or they can choose to ignore. And if the state chooses to ignore, the citizen gets to move again. And if they do, the citizen gets to choose between loyalty and exit. Loyalty and exit. Okay? And in parentheses here, 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 and here, we have the possible payoffs that are available to all the players. Okay, so here we have E, 1. Here we have 0, 1 plus L. Here we have 1 minus C, L. Here we have 0 minus C, 1 plus L. And here we have E minus C, 1. And in combo of both my maybe not great handwriting and the quality of the video, I think it's important to walk through all of that just to make sure you write the right stuff down. And then we have a set of assumptions here. And here we're saying E equals 2. Here we're saying C equals 1. And here we're saying L equals 0.5. So equipped with our assumptions, we can use our process of backwards induction to solve this game. So we're going to start by looking at the terminal node, the last player to move. It happens to be the citizen, who is also player 1 in this case. Right? Because player 1 is always the first player to move. Player 2 is always the second player to move. So because we're looking at player 1's choices here in the final node, we're going to be looking at the payoffs for player 1. So we're comparing the 2 options of loyalty and exit. And we need to compare these payoffs of 0 minus C and E minus C. These are the payoffs for player 1 for that node. Okay? So we actually happen to know exactly what E is here. E equals 2. If you wanted a piece of scratch paper or something, you could cross that out and write 2. Right? We know that equals 2. We also happen to know what C equals here. C equals 1. Right? So we can cross out C in both of these cases and write 1. So really we're comparing 0 minus 1 and 2 minus 1. 0 minus 1 equals negative 1. Negative 1. And 2 minus 1 equals 1. Player 1, they like 1 more than they like negative 1. Yeah? So we can prune this branch. Don't have to worry about it anymore. We know that the citizen, given the choice between those 2 options, they're going to choose to exit. Great. Now we can move on. We can move on to the next node. Right? Using backwards induction, we're going backwards. So let's look at the state and what the state's going to do. The state knows that if they respond, they're going to get the payoff L. We're looking at the second set of payoffs here. Right, the second payoff. Right, this is player 1's payoff, this is player 2's payoff. Right. So they know if they respond, they're going to get the value of L. And if they ignore, the citizen is going to choose to exit. Right? We got rid of that branch. Doesn't matter to us anymore. We know what the citizen would do given the choice between those two things. So the citizen is going to choose to exit. And we know in that case, the state is going to get a value of 1. So the state is choosing between a value of L and a value of 1. We happen to know exactly what L equals. L equals 0.5. So if we wanted, we could cross out L, right, 0.5 right there. So really, we're comparing values of 0.5 and 1. Right? So the state likes 1 more than they like 0.5. So they're going to choose to ignore. Right? So we can prune that branch also. Not important to us anymore. So from there we can move on to our final bit here. Looking at the first node, the citizen's first choice. The citizen knows that they can choose between exit, loyalty, and voice. The citizen knows that if they choose voice, the state is going to ignore them, and the citizen would be best off to exit in that case. Right? Those are the branches that are left after we've pruned these branches. Okay? So the citizen in this case is choosing between the values of E minus C, 0, and E. Right? And down here, we worked out what E minus C actually is because we know that E equals 2. We know that C equals 1. So we did 2 minus 1 equals 1. So they're choosing between the value of 1 here, 0 here. And again, we know what the value of E is here. So we could cross that out and write 2 if we wanted to. We're comparing the values of 2, 0, and 1. The citizen likes the value of 2 more than they like 0, and they like 2 more than they like 1. So they're going to choose to exit. Okay? So then it comes time to write the actual answer down, right? The actual strategies. And we always write them left to right, going this way. So we've done our process of backwards deduction. We now know our answers. So now we write them in actual chronological order, right? In the sequence of moves that the players would actually play. So we know that the citizen is going to choose to exit here. I'm going to write in capital E here, but really it's exit. No curveballs. You know, there won't be an option where it's either E or exit. That's not what I care about. Right? If you know it's E, you know it's exit, you're good to go. Okay, so that's the strategy for that node. We also need to account for the strategy from this node, right? And we also said that the optimal strategy there was to play exit. So here, let's write this a little bit more clearly. Give myself a little bit more space here to write with. Okay. Exit, comma, exit, semicolon, whatever player change strategy is. Right? Exit, because their optimal strategies are to exit and to exit. That's accounted for there. So we're done with player 1. Now we need to write in the strategy for player 2. Player 2, remember, gets to choose between respond and ignore. We pruned the respond branch, so we know that's not the right answer. Only other option was to ignore. That's the answer. Ignore. That's your final answer. Exit, exit, ignore. That's how you solve this exit voice loyalty game. One strategy that could be helpful is to write this part out as you go. right at the very beginning here, we knew when we were looking at this branch, this part of the tree here, when the citizen was choosing between exit and loyalty, we said they were going to choose to exit. Just write that in right there. You just do that right away. Remember, this is the last move of the citizen of player 1. So that goes in this last space available there. Right, and then we knew that the state was going to ignore instead of respond. You just write that in right there as you go. And then at the end of the game, we're looking at voice, loyalty, and exit for player 1, the citizen. We said that they're going to choose exit. That's the first strategy here, right? Because that's the first node. That goes in right there because we write from left to right. So exit goes in there. Exit, exit, ignore. And yeah, I think that that's the kind of thing that you will see on the quiz tomorrow. So if you can do this, you're golden. You're all set. So study up, enjoy, have a good night.